in this question, this is question 5. In the previous videos, we did question 5.1 all the way through question 5.5. Now we're going to do question 5.6. The question says, given h of x equal to 2x minus 3, and then for negative 2 less than or equal to x less than or equal to 4, the x-intercept of h is q. Now, question 5.6. Move here, question 5.6. It says, given h of x equal to f of x, where f is a function defined for negative 2 less than or equal to x less than or equal to 4, explain why f has a local minimum. All right, over here we don't have f, okay, but they tell us that f prime. The question tells us that f prime is h of x is equal to f prime. So the same graph here is now the graph of f prime. This graph here, h, is the graph of f prime of x. So now the question says that we need to explain why f, the function f, okay, has a local minimum. All right, I'm going to move my board over here. I'm going to move it over here. Okay, now I'm going to write question 5.6. So over here, it is, the question says that h of x equal to f prime of x. In other words, that f prime of x is equal to 2x minus 3. Now, we need to prove that why f of x, the function, has a local minimum. Okay. First of all, we can say that, you see, f prime of x being equal to 2x minus 3 is less than 0 in the interval. If you look at the question, it is in the interval negative 2 and 3 over 2. Okay, because I'm gonna put the graph here so we can all visualize the question again. Here's the graph of we did find previously that q, the x-intercept was given by 3 over 2, 0. Okay, so we can see that it is, if f prime of x is negative in this interval, okay, then we can say yes, because of that we can say that it has a local minimum at x is equal to 3 over 2, or else we can also work out the second derivative. The second derivative of x, of f of x, will be 2. 2 is more than 0. Yes, we can also say because of that, because f prime of the second derivative of f of x is equal to 2, which is positive. Therefore, f has a local minimum. Thank you. The question, the other question is question 6.2. Okay, we did question 6.1, 5.6.1. Now we're going to do 5.6.2. The question says, write down the value of the maximum gradient of the tangents to the graph of f of x. Oh, all right. Okay. First, we do know that the tangents is to a function is equal to, the gradient of the tangents is equal to its derivative. I'm going to write the question here. So we're looking for, they say write down the value of the maximum gradients of the tangents to the graph of f. We don't have the graph of x, but we have the derivative of f, which is h. Okay, we do know that that's 5.6.2. We do know that the gradient of the tangent is equal to the derivative of the function. So therefore, m will be equal to the derivative of f of x, which is f of x is h of x. Okay, now when I look at the highest point here, the highest value, the maximum value here is when x is equal to 4 in the graph. You looked at the highest boundary. We're going to sub there m equal to h of 4, okay, which is equal to 2x minus 3. Now we're going to substitute the value of x by 4, and then m will be equal to 5. So 5 is the maximum gradient for the tangents of f of x. Thank you.